How's it going, everybody? In this video, we're going to take a look at our next interface topic, which is going to be layer 3 subinterfaces on a firewall. So the idea is to take communication from router 16 and router 17 and be able to get them to communicate with each other through a subinterface. So we'll basically take Ethernet 1/4 right here. We'll add subinterfaces to it so that they are paying attention to the VLAN information, and then they'll be able to send traffic between 16 and 17. So this is very common in a scalable environment. There's been a number of branch offices that I've worked with where you don't go out and deploy a really big switch or router. You get some sort of smaller enterprise grade router or firewall, and you rely on VLAN segmentation at the branch office. And so then you have maybe a pair of routers, but you're a flat layer 2 switch that is just going to be able to take VLANs. You create VLANs, you apply them to the ports, and you have a trunk link going up to the routers so that they can do the .1Q subinterfaces. They're your router on a stick, your high availability, that type of stuff. So we're going to take a look at exactly how that type of stuff comes into play here and go from there. So with that being said, let's go ahead and take a look at our config. It's actually pretty straightforward, but there's a number of steps that we have to go through in order for this to work. So let's go ahead and dive into this config. Let me go ahead and get out of the way. So what we're going to do is we're actually going to go on Ethernet 1/4. I'm going to come in here, and we need to make this guy a layer 3 interface. So I'm going to come down here, make this layer 3, and that's all we have to do. We don't have to do anything else to this configuration except for create specify the interface type as layer 3. I'm going to click on OK there. Now the next thing I have to go do is create subinterfaces. So with 1/4 still enabled or highlighted, I'm going to click on Add Subinterface. And then I'm going to come underneath here and type in 16, which is going to be the interface identifier. Then underneath here I'm going to type in 16 for the VLAN ID, or the encapsulation that we're going to be looking for. The virtual router is going to be default. And the security zone that we're going to create, we don't have one created for yet, so I'm going to call this sub int and click on OK. And I'm going to come over here to IPv4, add an IP address, and this guy here is going to be 10.1.16.1/24, and click on OK. So that's one subinterface. The next one we're going to do is the same thing. We're going to create, this one's going to be .17, tag ID is going to be 17, the virtual router will be default, and the zone will be now subint. So we're going to go to IPv4, add an address. This guy here will be 10.1.17.1/24, and click on OK. And that's pretty much it. So we've got the zone created. It's been mapped to the interfaces, so we're in good shape there. So we're going to go ahead and commit that config, and that's pretty much all we need to do. So I'm going to go ahead and commit that config. I'll pause the video and I'll wait for that to finish, and then we'll focus on the Cisco networking here in just a moment. So we'll look at the switch, I'll talk about what needs to be done on that, and then we'll take a look at the router config and how that comes into play, as I don't want to assume you guys already know that. Okay, so our configuration was completed correctly. So we're going to go ahead and I'm going to come over here to the monitor tab so we can see communication here in just a minute. I'm going to pull up Secure CRT. So one of the first things we want to do is on the switch, we're going to come over here and we want to make sure that VLAN 16 and 17 have been created. So show VLAN brief. We have VLAN 16 and 17 have both been created right there. So which means you just go to global config and you type in VLAN 16, hit the enter key, VLAN 17, hit the enter key. And then if we do show run, we're going to look at the first couple interfaces, gig 1 and gig 2. We're going to see that on gig 1, where switch port access VLAN 17, switch port mode is access. Same thing with 2, switch port access VLAN 16, switch port mode access. So that means it puts those individual ports into those individual VLANs. Then what we do is a do show run, and we look at gig 0/0, which is right here, switch port trunk encapsulation .1Q, switch port mode trunk. So basically what it's going to say is between switch 1 and PA 1 go ahead and convert this port to be a trunk to allow multiple VLANs to cross the trunk. So that's going to be pretty much a given anywhere you go. And then on the routers, this is where the routing piece gets a little bit interesting. So when I was testing this, you have to be kind of specific here. So by default, a router will automatically look in its routing table to figure out where to forward traffic. If it doesn't know how to forward the traffic, it's going to drop it. So when I did some testing before this, it was failing. And I'm like, okay, why is it failing? And I had to think about it for a second, because I don't normally use routers as endpoints. Normally you use a PC and you just give it the information that it needs and you're in good shape. Well, basically the router is its job is to route. So if you're trying to make it act like an endpoint, it's going, well, gee, George, I don't know what to do. Which is, you need to either tell it where to send the traffic, because routers are dumb, right? They don't understand anything until you tell it what to do. So what you do is on the routers, you either give it a default gateway through the IP default gateway command, which is right here. So you can turn routing off, no IP routing. IP routing being turned off will basically turn the router into a PC. And it'll be like, well, I don't know what to do. You have to tell me where I need to go. We can keep routing enabled and just create a default route. So on this router here, I said no routing. So let me actually go ahead and type in host name is going to be iOS 16, just so it's easier for you guys to see. So we have that. Then I typed in no IP routing. Right, I typed that command in, which turns off the routing process on the router. And then if you do show IP route, I have the IP default gateway command. So do show run pipe include default. I have the IP default gateway command configured saying IP default gateway 10.1.16.1 or point towards Palo Alto 1 in order to leave the 10.1.16 network. So on router 17, I can do the exact same thing. I'm not going to. I'm going to give you a different variation of the same configuration. So host name is going to be iOS 17. I'm going to type in IP routing, which is going to turn the routing process back on. Okay, but I'm going to type in IP route, a default route, to 10.1.17.1. And what that basically is going to say is if you don't know where to send the traffic, send it to firewall 1, or in this case here, Palo Alto 1. So do show IP route, again, this time here it's going to say, if you don't know where to send the traffic, send it towards the firewall. The firewall will figure out what to do from there. So on 16, if I come out here and I type in ping 10.1.17.17, the ping should go out. And there it goes. If we come over here, we can see the ping flows through the firewall as it's expected. And everything looks good from there. And you can tell which zone it's in based off of this information right here. So I'm going to leave the configuration in play the way it is right now, because I can go and in follow-on videos, we can go and create different security policies and test connectivity between point A and point B and things like that. So that'll give us a lot of flexibility in those respects. So that's basically where that process comes into play. So with that being said, that's where we are with that. So we still have a few more minutes left that I want to talk real quick. We have on the network tab and on the interfaces, we have a virtual wire created, right? Well, the one thing that I haven't talked about here is going to be the VLAN interface. I haven't done tunnels either, but we're going to talk about tunneling in an upcoming section once we get a little bit further along, because right now we're focused still on just firewall communication on directly connected interfaces. So what I'm going to do is I'm actually going to flip Ethernet 1/2. Actually, you know what? I'm going to do this in a different video. I'm going to convert it back over to a layer 2 connectivity and do a VLAN interface just so you guys can see what that looks like, because the vWire is cool and all, don't get me wrong, but the VLAN interfaces makes more sense because that gives me more flexibility in terms of operations and things like that. So we've validated communications working the way we wanted to, which is what we set out to do. Until next time, guys, thanks so much for stopping by and hanging out with me, and we'll catch you guys in the next video.